Okay, so now let's do a couple of examples using the three methods that we found in order to find the, for example, mean of a couple of observations. Let's see how we can do that. So for example, we have example number 2 here. The table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories of India. Find the mean percentage of female teachers by all the three methods discussed in this section. Okay, I didn't understand the question really. So it says the table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories of India. Find the mean percentage of female teachers by all the three methods discussed in this section. Okay, so the table that we have is just some data. For example, let me show you what the data is. So the data is something like this. You have the percentage of female teachers. You have the percentage of female teachers. And you also have the number of states or union territories. The number of states, or UN means union territories. So they have classified the data into different classes. For example, 15 to 25. Then we have 25 to 35. 15 to 25 is 10. 25 to 35. Then you have 35 to 45. Then you have 45 to 55. Then you have 55 to 65. Then you have 65 to 75. And then you have 75 to 85. And the percentage of female teachers, what that means is that if the percentage of female teachers fall within basically this category, which goes from, for example, 15% all the way up to 25%, that would correspond to, for example, 6 states or union territories. If the percentage of female teachers basically corresponds to 25% to 35%, that corresponds to 11 territories. And in the same way, you have 7, you have 4, you have 4, you have 2, and you have you have 2, and you have a 1, right? So now what we want to do, we want to find the mean percentage. So this is the percentage of, so we want to find the mean percentage of female teachers by all the three methods discussed in this section. Okay, so now let's see how we can find the mean percentage in the case of this data. And So in basically we had three methods that we talked about. So the three methods that we talked about were the direct method, the assumed mean method, and the step deviation method, right? So we had basically something called the direct method, which was basically x bar is equal to x of I times f of I over basically sigma x of I times f of I over sigma f of I, and that was the direct method, meaning that you take all of the frequencies, basically meaning that you need to take an x of I, for example, relative to each of these classes, and each of those x of i's you have to multiply it by the corresponding frequency, and once you do that, then you divide it by sigma f of I, and that gives you x bar, and that was basically the direct method. There was something else called the assumed mean method. The assumed mean method, and what that was that we took we took basically x bar as a plus sigma f of I times d of I over sigma f of I, and that was the assumed mean method. In case you have forgotten what this was or how you would do these, we will go over them one by one in order to understand it. And then there was another method called the step deviation method, in which case x bar is equal to a plus h times sigma f of I u of I over sigma f of I, and that is basically the step deviation method. Okay, so now I'm going to make a screenshot of here. If it's at all possible. Okay, so now I'm going to make a screenshot here, and this is not a good one. Okay, so now the direct method is basically sigma x of I f of I over sigma f of I. And so for this method, what we need is basically we need to calculate. We need to have some x of I, which we don't have in this table, and then we need to calculate x of I times f of I, and then we need to calculate sigma x of I f of I, and also we need to calculate sigma f of I, right? So the things that we need here is basically first of all x of I, then f of I times x of I, then we need sigma x of I times f of I, and also we need sigma f of I. So these are the things that we need to add to this table, right? So I'm going to create a new table based on this table, and I'm going to write, for example, the percentage of female teachers, or I'm just going to write this as class. I'm going to write them as class intervals. I'm going to write that as class intervals. And then so these are my class intervals, for example, 15 to 25. Then I have, and let me write this a little bit more conservatively, because there are a few things that we still need to add to this table, so I don't want to run out of space. I'm going to write this as class intervals, right? 15 to 25, 25 to 35, 35 to 45. You have basically 45 to 55. You have 55 to 65. You have 65 to 75. You have 75 to 85. Right? Now these are your class intervals. Then you have the number of states or basically union territories. I can call that the frequency related to each class interval, so that I can call that f of I basically, right? So that basically I can call this f of I, and then that would be, for example, 6, 11, 7, 4, 4, 2, and 1. And so now what I need is some x of I. So your x of I, we do need to calculate there was something called the middle class or something. Class march. So we need to calculate the class march, which you can call x of I, right? So now your class mark over here, for example, would be 25 plus 15, which is equal to 40. 40 divided by 2 is equal to 20. 25 plus 35 is equal to 60, that would be 30. 35 and 45 together, added together, would be 80, so that's a 40. 45 plus 55 is equal to 100, so that would be a 50. 55 plus 65 is equal to 120, 110, 120, so that's a 60, 70, and 80. So you can see that the difference between all the respective class marks is 10, and that's actually equal to the class interval, or the class size. The class sizes are 10 to 25, 10, 25 to 35, 10, 35 to 45, 10, 45 to 55, 10, and so on and so forth. Okay, so now we have our x of i's, and so now we can calculate f of I times x of I. So f of I times x of I is going to be equal to 120, 330, 280, 200, 240, 140, and 80. And then based on that, sigma f of I x of I, based on that, sigma f of I x of I is equal to all of these numbers added together, which is basically 400, 450, 650. So you have 650 plus 80, and you have 200 here. 200 plus 240 is equal to 440, 580, and you have 580, and then you have 80 over here, so you have 0. 13, 13 plus 16 is equal to 29. So you have 8, 8 plus 5 is equal to 13, that's 1390. That is 1390, right? And then you have basically your sigma f of I x of I calculated. Now, so this is also calculated. Now sigma f of I, sigma f of I is equal to all of these numbers added together, so that's 11 plus 6 is equal to 17. So you have 17 plus 11, 17 plus 11 plus 7, which is equal to 15, 1, that's 35. So that means that basically then, based on the first method that we had, which is the direct method, based on the direct method, we said that basically x bar is equal to sigma f of I times x of I over sigma f of I. Sigma f of I times x of I is equal to 1390, and sigma f of I is equal to 35. And if you do this division, you will get 1390 divided by 35. You will get 104 times 35 is equal to 120, 140. 3 times 35 is equal to 90, and 105. So you have 4, 3, and 4, 0. Then you have 9 times 35 is equal to 270, and 45. So that's 5, 11, 315. 9 times that is equal to 315, that's a 5, 2, and you can put the decimal point here, 0 decimal point, and 6 times it is equal to 180, and 6 times is equal to 30, which is equal to 210. 7 times 35 is equal to 210, and 35, that's 245. So 7 times would be 245, and that's basically a 5 remainder, and then if you put a 0 over here, you will get 1 times basic 35 is 35, so that's 39.7, approximately 39.7. So this is basically your mean based on the direct method. Now we had another method which was basically called the assumed mean method. The assumed mean method, and in the assumed mean method we said that x bar is equal to a plus sigma f of I d of I over sigma f of I. Now we took d of I over here, we took d of I as let me see what we did over here. So what we did over here was that basically we so you have your f of I and you have your x of I, right? So now what you can do is that you can take one of these numbers as your assumed mean. I call it a, for example, and then I need to calculate the deviation of each of these x of i's from this a. That means that d of I, if I call it the deviation of each of these x of i's from a, is equal to x of I minus a, right? So if I do that, what I will get is, for example, d of I here would be equal to basically x of I minus 50, so 20 minus 50 is equal to negative 30, and 30 minus 50 is equal to negative 20, negative 10, 0, 10, 20, and 30, right? And then what I need here is sigma f of I d of I. So sigma, so I need to calculate f of I times d of I. F of I times d of I. So f of I times d of I is this column times this column. So 6 times negative 30 is equal to negative 180. 11 times 20 is equal to negative 220. 7 times negative 10 is negative 70. And 4, that's a 0, that's a 40, that's a 40. And that's a 30, right? Now, sigma f of I d of I, based on this, sigma f of I d of I is equal to all of these numbers added together, which is 80, 110. So you have 110 there, and you have negative 300, 400, 470. So negative 470. So I write 470 and I have a negative sign there, 0, 6, and 300, negative 360. So I get A as 50. I get A as 50 plus sigma f of I d of I, which is negative 360, over sigma f of I. Sigma f of I is 35. Now, negative 360 over 35, let's take it as 360 over 35, which is something below 10. above 10, I'm sorry, 360 over time divided by 35 is equal to 1 times 35 is equal to 35, 10, and then 0, and then 3 times 2 times is 70. Have 30 remainder, 0, 0. 9 times 35 is equal to 270 and 45, so that's 315. 8 times 35 is equal to 240, and 8 times 5 is equal to 4, that's 280. That's 280, and then you get a, so I take that as 1.3, right? So that's negative 1.3. That is the same thing as 50 minus 1.3, which is equal to which is the same thing as 49.7. 49.7. I might have made a, I have actually made a mistake somewhere. And the mistake that I have made is either this one is wrong or the other one is wrong. Let me see which one is wrong, and then we will take care of the problem. $39.7. This is right. I have made a mistake somewhere over here. Okay, so sigma f of I d of I. So if I take x d of I as x of I minus a, if I take a as 50, then 20 minus minus 50 is equal to negative 30. That's negative 20. And that's negative 10, that's 0, and so on and so forth. So sigma and f of I times d of I would be negative 180, negative 220, negative 70, 0, 40, 2 times 10 is equal to 40, and 1 times 10 is equal to 30. Adding all of these together, you will get 80, 110. Let me use a calculator. So you get 30 plus 80 minus 70 minus 220 minus 180 is equal to negative 360. That is correct. I want to calculate sigma f of I d of I by sigma f of I, which is equal to 35. And I took a as 50. So you have to write this as 50 plus 360 by 35. 360 by 35 is equal to, I'm sorry, 360 divided by 35 is equal to 10. Oh, that's 10 point something. That's 10.3. That is 10.3, and that gives you basically the same number. So that's basically that's 4039.7, the same number here. Okay. Now the next method that we can use, and we had, was basically the step deviation method. Was the step deviation method. And the step deviation method was basically x bar is equal to a plus h times a plus h times sigma f of I u of I over sigma f of I. That was basically that. So now my h is, of course, my class size, which I know is 10. My a is 50, that I know already as well. Now the only thing that I need to calculate is u of I, and then u of I times f of I, and then sigma f of I u of I. So now we defined u of I as, well, basically what I can do is that you can see that all of these numbers are multiples of 10, and a multiple of 10 meaning a multiple of the class size. The class size here is 10, and these are all multiples of 10. That is negative, that is basically negative 3 times 10, that is 2 times 10, 1 times 10, again 1 times 10, 2 times 10, and so on and so forth. So if I define u of I as basically d of I divided by h, define u of I as d of I divided by h, d of I divided by h by the class size, I can write that as basically x of I minus a over h. X of I minus a over h. So I can write this as x of I minus a over h. So what that means is that I can write x of I minus a, which is d of I, and divided by h, which is 10. So divide this by 10, you'll get negative 3, negative 2, negative 1 times 10 is equal to 10, 0, 1, 2, and 3, right? And now I have my u of I. Now f of I times u of I is equal to basically 6 times, that's negative 18. 11 times negative 2 is negative 22. That's negative 7, that's 0, that's 4, that's 8, and that is 3. So that is basically u of I times f of I. And then you can calculate sigma f of I times u of I, which is equal to all of these numbers added together. That's 12, 15. And then here you have 29, 39, 49, 47, negative 47, and you have a negative sign there. We have 2, negative 32. That is negative 32. So now now that I have sigma f of I u of I, and I have all of the other values that I need, I can write x bar is equal to a, which was over here 50, which is this value over here. This is 50 is equal to a. So a is equal to 50, h is equal to 10, times basically sigma f of I u of I, which is equal to negative 32, over sigma f of I, which is equal to 35. So to calculate that, you get, I think we already have this number over here. Or we might actually have made a mistake here. Let me see if this number is correct, and then we will move on with this. So you have 11 plus 15 minus 7 minus 22 minus 18. Negative 32 is correct. And then if you divide 32 by 35, you will get 0.9114. and 10 times that is equal to times 10 is equal to this, and 50 minus this number is equal to 40.8. There is something wrong here. There is something wrong here, so let me see. X sub I minus A divided by H, negative 2, negative 1, 0, 1, 2, 3, and then you have 20 times 20 times negative 3 is f of I times u of I. 6, that's negative 18, negative 22, negative 7, 0, 4. Oh, that's a 4, right? That's a 4 and that's a 3. So then your sigma u of I f of I is going to be 11 is going to be 11 minus, for example, 7 minus 22 minus 18, which is equal to negative 36. Negative 36. So you have negative 36 by 35, which is the same thing as 50 plus negative 360 divided by 35, which is again the same number here, which is equal to 39.7. So you have 39.7, 39.7, and 39.7 here. So, except for the careless mistakes that I sometimes make, the methods actually do work and give you all the same answer all the time. So you cannot go wrong with any of these methods. And of course, you know that you don't actually need to do basically all the three methods all the time. If your numbers are simple, you can well enough go with the first method, which is the simplest method. Only calculate x sub I and then multiply by f of I, find sigma f of I x sub I, divide by sigma f of I, you will get your x bar. If your numbers need a little bit more simplification, you can proceed to the second method, which is actually an extension of the first method. If again your numbers need a little bit more simplification, you can go with the third method. But all the three methods are actually one and the same thing, meaning that you do more steps, you will get the second method, you will get the third method. Otherwise, they are the exact same things. So that's basically that. Now let's do another example here. So here we have a remark here. It says that the result obtained by all the three methods is the same. So the choice of method to be used depends on the numerical values of x of I and f of I. If x of I and f of I are sufficiently small, then the direct method is an appropriate choice. If x of I and f of I are numerically large numbers, then we can go for the assumed mean method or step deviation method. If the class sizes are unequal and x of I are large numerically, we can still apply the step deviation method by taking h to be a suitable divisor of all the d of i's. So you can basically do any of the three methods as long as you understand what you're doing, right? I don't know what these are. Okay, so now let's do another example here. All of these examples are basically they teach you a point, but of course there is a lot of them in this part of the book, and we cannot go through all of them. We will go through enough of them. I have already gone through all of them, but it's not really, I mean, you would need at least 10-15 videos to go through all of these examples and exercises, so you'll have to pick the right ones. So now we have example number 3, which is the distribution below shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does this mean? What does the mean signify? Now I don't understand the concept of cricket, so I'm going to pass this one. And then we have a couple of exercises. So we can do a couple of exercises here, preferably the ones that are not related to cricket. So a survey was conducted by a group of students as part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants per house. So you want to find the mean number of plants per house. So basically the data that we have is we have the following data regarding the number of plants in 20 houses in a locality. So 1, 2, 3, so that's 4 plus 5 is equal to 9, 9 plus 11 is equal to 20. Okay. So now suppose that, for example, you have this method here, you have this this data here, and this is here you have the number of plants, and then you have the number of houses, So if that is the case, let's say that if the number of plants were 0 to 2, that corresponds to 1 house. 2 to 4, that corresponds to 2 houses. 4 to 6, that corresponds to 1 house. 6 to 8, that corresponds to 5 houses. 8 to 10, that corresponds to 6 houses. And 10 to 12, that corresponds to 2 houses. And 12 to 14, that corresponds to 3 houses. Now what that means is that basically the data that they have collected has been basically this way. For example, they had for example, the number of plants in one house has been some number between 0 and 2. The number of plants in 2 houses has been some number between 2 and 4. Actually 2 or 3 in this case. The number of plants in one house has been some number either 4 or 5. The number of plants in 5 houses has been some number either 6 or 7, or 8 or 9 in 6 houses, and so on and so forth. Now, in order to find the mean of this data, what you need to do is, but of course you can, the number of houses, basically the number of plants are your class intervals. So you can specify your class intervals here, so you can call this your class intervals, and then you can write all of your class intervals over here. For example, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and 10 to 12, and then you have 12 to 14. Then you have 12 to 14. And then the number of houses is basically the number of houses is basically the frequency of those class intervals. You can call this f of I. So this was 1 to 1. This was 1 to 1, 5, 6, 5, 6, 2, and 3. So now you want to calculate, for example, x bar, right? So to calculate x bar, we said that using the direct method, what we could do is that we can write sigma x of I times f of I divided by sigma f of I as I goes from 1 to n, right? So let's see what happens if I calculate x of I here. So my x of I is going to be the middle point of each class, meaning that, for example, 2 divided by 0 is equal to 1, 6 divided by 2 is equal to 3, 10 divided by 2 is equal to 5, and 14 divided by 2 is equal to 7, then you will get 9, then you will get 11, and then you will get 13. So this is your class, what do you call it? I keep forgetting this thing, the name. This is called the class march. This is called the class march, which you can take as x of I. Now if I calculate, it's still very easy to calculate f of I times and x of I, meaning that I can write x of I times f of I is equal to, for example, 1 and 6 and 5 and 35 and, for example, 54, 22 and 39. And then based on that I can calculate sigma f of I times x of I, which is equal to 12. So you have 12, 35, 76, for example, and 39. And that's a 15. 15 plus 7 is equal to 22. We have a 2 over here, 6, 13, and 16. 162. And you can calculate your sigma f of I as basically 4, 9, 15. 15 plus 5 is equal to 20. So that's the same thing as 162 by 20, which is the same thing as 81 by 10, which is equal to 8.1. Right? So that is the mean of your data. Let me find the answers over here. So the answer is correct, 8.1, and of course we used the direct method because we didn't really need to use any of those other methods like the step deviation method or the other one, which was basically the assumed mean method. And so what that means is that what the answer means is that basically these were the number of plants in 20 houses, and so that means that basically on average we have about we have about 8.1. So we have 162 plants, right? So the number of plants here was, okay, so we have 162 plants is in 20 houses. That means that on average we have something about 8 plants in every house. That's basically the meaning of the mean in this, for example, in this example and in this context. Or let's say that you have another example. Let's do another example here. Yeah, of course. Or consider the following distribution of daily wages of 50 workers of a factory and find the mean daily wages of the workers of the factory by using the appropriate method. Okay, so for example, this table shows you the distribution, the daily wages of 50 workers of a factory. So you have the daily wages here, you have the daily wages here, and then you have the number of workers there, right? And then you have, for example, these class intervals 500 to 520. You have 520 to 540. You have 540 to 560. You have 560 to 580. And then you have 580 to 600. And the number of workers for each category were 12, 14, 8, 6, and 10, right? Now you want to find the mean of this data. So now this data is a little bit different from the data that we had in the previous examples, meaning that the class intervals are a little bit too large. So now we will see, I'll show you what I mean by that while we are solving the problem. Okay, so now in order to basically find the mean of this data, for example, what you can do is that basically my daily wages, I can think of them as my class intervals. So the class intervals are basically the daily wages, and so I can write, for example, 500 to 520. I have 520 to 540. I have 540 to 560. I have 560 to 580, and I have 580 to 600. And then the frequency related to these class intervals are, you can call your f of I, and that is 12, 14, 8, 6, and 10, right? And then you need to calculate your x of I, because your formula in the simplest form, meaning that using the direct method, you have basically x bar is equal to basically sigma f of I times x of I divided by sigma f of I as and so I need my sigma f of I x of I. So now my x of I is my class march. And my class mark is basically the average of the upper limit and the lower limit and the upper limit of each class interval, or each class basically. So that's, for example, 1020, which is the average of that would be 510, for example. 510. Over here you have 5,000. You have basically 1060, which is 530, and then you have you see that basically 510 plus 20 is equal to 530. Again, 540 plus 560 is equal to 1100, which is 550, half of that. And you can keep adding 20 to these numbers to get to the last one. So 570, 590. And so now, if I want to calculate, for example, x of I times f of I, the problem is that I have to multiply 12 times 510, which is something around above 6,000 or so. So the numbers will get too unwieldy, too large, right? So I need to go with at least not the direct method, but the assumed mean method. So in the assumed mean method, we said that basically x bar is equal to a plus sigma f of I times d of I over sigma f of I, if I'm not mistaken. It's a plus sigma f of I over sigma f of I. Okay. So now what that means is that I need my, basically, the f of I already have it, but d of I have to calculate it. So in order to calculate d of I have to find some number over here in my x of i's and take it as the assumed mean. So I take this number as my assumed mean. And then over here I have to calculate d of I. I have to calculate d of I, which is x of I minus a. So for example, 510 minus 550 is negative 40. You see that the numbers are getting way too smaller than the numbers that we had before. 530 minus 550 is equal to negative 20. 550 minus 550 is equal to 0. That is a 20 and that is a 40. And you see that these numbers are already a multiple of 20. So 20 times 1 is 20, times 2 40, times 1 20, times 2 40. And meaning that your d of i's are a multiple of your class size. So now what I can do is that I can calculate f of I times d of I. F of I times d of I. So f of I times d of I is these two columns multiplied together. And again, you can see that the numbers get too large, meaning that this number would be above 2000, for example, which is still not the right thing to do. So I don't want to go with this one either. I want to go with the basically the step deviation method. So in this step deviation method, what you will do is that you can write x bar is equal to a plus h times basically sigma f of I times u of I over sigma f of I. So now my h over here is the class size, which is 20, a is 550, and then I can calculate f of u of I as well. So u of I is basically the same thing as d of I divided by the class size. D of I divided by the class size, which is basically h here. So I can write u of I as, for example, over here negative 40 divided by negative 40 divided by 20 is equal to negative 2. That's negative 1. 0 divided by 20 is 0. 20 divided by 20 is 1. And 4 divided by 20 is equal to 2. Now the numbers are small, and if I want to calculate f of I times u of I, that would be, for example, 12 times negative 2, 14 times negative 1, and so on and so forth. So now I can write, for example, negative 24, negative 14, and this would be 0, and as 1 times 6 is 6, 2 times 10 is equal to 2 times 10 is equal to 20. And so based on this, you can say that your basically you can say that sigma f of I u of I over here, sigma f of I u of I is equal to, basically this is 26, and that is negative 38. So 38 and 26, and you have a negative sign there, so the 2, that's a negative 12. That's a negative 12. And sigma f of I is equal to, that's 26. 26 plus 36 plus 14 is equal to 46 and 50. That is 50. So this is 26, 36, 36, 46. 46 plus 4 is equal to 50. Okay. Now I can write this as A, which is basically this is your A. So 550 plus basically h times, h is 20, times basically this fraction, which is f of sigma f of I u of I, which is negative 12, divided by sigma f of I, which is 50. Now this is 25, 6, and divide by 5, you will get 4, divide by 5, you will get 5. And you have basically 6/5 is 1 point something. So let's write this as 550 minus 24/5. 24/5, which is the same thing as, I don't know what is 24/5. I don't wanna 24, let me calculate it here. So 24/5 is the same thing as 4 times 5 is equal to 20. So you have a 4 here, and 0. 8 times 5 is equal to 40. So that's 4.8. That's 550 minus 4.8. Which is equal to basically 550 minus 5 is 545. So that's 545.2. 545.2. That's the average, the mean of your data. And that was example number 2. 545.20 is and that is basically the average salary, meaning that every worker gets on average 545.2 rupees. Basically, these are all in rupees, meaning that these are all in daily wages in rupees, and these are the number of workers corresponding to those wages, to those wage classes. So that means that there were 12 workers whose daily wages were between daily wages, of course, daily wages between 500 and 520 rupees. There were 14 workers whose daily wages were between 520 and 540 rupees, and so on and so forth. So now that we have calculated the mean of this data, so what that means is that the daily wages of any worker is on average 545.2 rupees. Somewhere over here. So that's basically, for example, that. So you saw that basically in this example, we had to go all the way through and use all of the methods that we knew. But of course, logically, always start with the direct method, which is the simplest method. But in that method, the numbers of course, are not treated at all. When you use the assumed mean method, the numbers are treated once, and when you use the step deviation method, the numbers are treated twice. And every time that the numbers are treated, then of course the numbers get smaller and easier to deal with. So that is basically that. Now let's do one more example, and then we will end this video. Okay, so the next example, and I think that's going to be the last example related to these formulas, is basically the following distribution shows the daily pocket allowance of children of a locality. The mean pocket allowance is 18 rupees. Find the missing frequency. So this is a good example, for example. Now I'm using the word example many times in a sentence. So let's say that your daily pocket allowance, I will call this daily pocket allowance, okay? Daily pocket allowance, and this is the number of children. So let's suppose that your daily pocket allowance is 11 to 13, and these are all in rupees, of course. These are all in rupees. So if it's you have 11 to 13, you have 13 to 15, you have basically 15 to 17, you have 17 to 19, you have 19 to 21, you have 21 to 23, and you have 23 to 25. And the number of children related to these class intervals is 7, 6, 9, 13, 7, 6, 9, 13, and F, and 5 and 4. So here I know that the mean pocket allowance, here I know that the mean pocket allowance is 18 rupees. So you want to find the frequency related to this class interval. So if I write my class intervals in this way, so let's say that these are my class intervals, and basically 11 to 13, and you have 13 to 15, 15 to 17, 17 to 19, 19 to 20, 21, 19 to 21, 21 to 23, and 23 to 25. And then the frequency related to these class intervals have been 7, 6, 9, 13, F, 5, and 4. Okay. So now, and I know that the mean pocket allowance is 18 rupees. So if I, based on this, if I calculate my x of I, which is basically the class, I forgot that again. This is the class March. This is the class March. So that is 24 divided by 2 is equal to 12. 28 divided by 2 is equal to 14. 20, that is 12, so that's 32. That's 15 plus 17 is equal to 15 plus 17 is equal to 32. 32 divided by, that's a 16. 17 plus 19 is equal to 16, 36, 18. And you can go 20, 22, and 24. And then if I calculate my sigma, basically x bar is equal to sigma f of I x of I over sigma f of I. So now f of I times x of I here, f of I times x of I is equal to basically we can use this formula. It would be much simpler. I don't know what happens if I started calculating, basically if I go for the other two methods. Let's try that. Let's see what happens. So let's say that you want to use the other method, which was basically the assumed mean method. So in the assumed mean method, we said that x bar is equal to a plus sigma f of I times d of I, and divided by sigma f of I. So now I need to calculate my d of I, which is equal to x of I minus a. So I can take, for example, this value as a, and d of I x of I minus a will be 12 minus negative 6. 14 minus 18 is equal to negative 4, negative 2, 0, 2, 4, and 6. And so that is, now if I calculate sigma f of I times d of I, or f of I times d of I, what I will have is basically negative 42, negative 42, negative 24, you have negative 18, you have 0, you have 2f here, you have 20 here, and you have 24 here. So now sigma f of I d of I is going to be equal to basically 64 plus 2f, 64 plus 2f and over here you have 18, 24, 42, which is equal to 42, 24, 18, negative sign, 14, 1, 2, 4, and 84, negative 84. Now negative 84 plus 64 is equal to negative 20 plus 2f. That's negative 20 plus 2f. So that means that sigma alpha by d of I is equal to negative 20 plus 2f, and I take my a as basically this thing, 18 here. So, and I know that my mean pocket allowance is 18 rupees. So that means that my x bar is equal to 18. So I write this as 18 is equal to 18 plus sigma alpha by d of I, which is equal to negative 20 plus 2f, divided by sigma f of I. Sigma f of I is equal to 13. 13 plus 9 is equal to 22. 22, 32, 35, 35, 38, and 42, 42 plus f. 42 plus f. That is 42 plus f. So now you can simplify 18 and 18 from these sides, from this side of the equation, and that means that negative 20 plus 2f over 42 plus f is equal to 0, which means that negative 20 plus 2f is equal to 0, which means that 2f is equal to 20 or f is equal to 10. That's the frequency of this class involved here. This is equal to 10. So that's basically, it's 20. Might have made a mistake somewhere, I don't know where. Let's see. Now I might have made a mistake in these calculations, probably. So let's say that you have sigma f of I is equal to 769, 7 plus 6 plus 9 plus 13 plus 5 plus 4 is equal to 44. Oh, that's 44. That is a 44. But that still doesn't really matter. 44 plus f. There must be something wrong here. Let me calculate these numbers. We have 24 plus 20 minus 18 minus 24 minus 42, negative 40. Oh, okay. That's actually a negative 40. I don't know how that happened. But that's supposed to be a negative 40 plus 2f. And if that's the case, so let me rewrite this whole thing and this part as well. So then basically x bar is equal to a plus sigma f of I divided by sigma f of I, which is equal to negative 40 plus 2f over sigma f of I, which is 44 plus f. Now since you can simplify 18 and 18 from both sides of this equation, what that means is that negative 40 plus 2f divided by 44 plus f is equal to 0, which in turn means that negative 40 plus 2f is equal to 0, which means that 2f is equal to 40. That means that f is equal to 20. So f is equal to 20. Is equal to 20 and not 10. Okay, so that is that. Now the next thing that we have here is, let me see, what is left in this part. Okay, so in the next video we will talk about the mode of group data. So I'll see you in the next video.